Hey Sierra, how you doing? What questions do we have today? I mean, the snack right here. Some quests. So go ahead and put those questions in the chat. Maybe we'll do the homework. Let's see here. Let's get the homework up. We should do some homework. Homework is always good to do. Pearson homework. Let's see if there's any questions in the chat. Throw out some points from Ubot. I think we did all of chapter 3 homework. Let's start some chapter 4. Let's do all of chapter 4 homework. If you have questions, it was kind of related to past class, but we're going to watch the full videos of them. Which class are you in, Sierra? Are you in 201, Sierra? Are you in 201, 320? Which class are you in? 201? For 201, let's go show that here real quick. For stat 201, let's go here in 1 second. Sure, got everything open on screen I want to open. Here we go. Let's check it out. For stat 201, make sure to go right here to where it says 201 and then click watch class live. Watch class live. That'll take you to the link. So it'll bring you to this link right here. Open a new tab. That'll bring you to the playlist with everything marked. So go to the watch class live button and that has everything right there to watch class live. And then it's the recordings also. So I can see how it's a little, like, it says watch class live, but it's recordings. So here we go right there. Let's do some chapter 4 homework. First question right here. Thank you for that question. 50 points for asking the question right there. Always let me know when you got those questions. That way I can answer them. Okay, so this is Stat 201, chapter 4 homework. Question 1. Let's talk about how to do this. All right, so chapter 4 is about comparing distributions. I'd have your notes open to take a look at what we've been covering. Got a lot of notes here. Where's chapter 4? Here's chapter 4. All about box plots, comparing distributions. You can see right here how we find the outliers in the box plots. And, oh, there we go, comparing distributions. So we want to be able to compare groups right here with different summary statistics. We can compare the shapes of them. We can compare the summary statistics of them. We can do stacked histograms right here. These are called stacked histograms. Very important. They have the same common horizontal scales to them. The 5-number summary is the min, the median, the Q1, the Q3, and the max in this particular order. Think about dividing your data up into quarters. Box plot is the way to visualize the 5-number summary. Let's give it a quick overview. The box of the box plot is the IQR. The median is the line in the middle. And the outliers begin where the fences are. Now, the fences are removed in the final product. You don't see the fences at the end. Sometimes we put a star for extreme outliers. You notice down here there's no data below 0. Remember, the fence is removed at the end of this, so you don't see where the outliers begin or end. 1.5 is a very important number for 1.5 IQRs above Q3 or 1.5 IQRs below Q1. And that denotes where outliers begin and end for data, at least from distance from the box plots Q3 and Q1. So kind of a quick overview right there. Multiple box plots can be used to compare multiple distributions. So box plots plural, this is box plots, can be used and are ideal. Box plots are ideal for comparing multiple distributions. They are ideal. If you see they're not ideal, that's false. I think that's got it. What's down here? Outliers. Outliers can do anything to data. They can drastically change the mean. They don't impact the median, so they can't do anything. We want to see what causes them and the reasons outliers exist in data. Like maybe it's from the change in distance of the Kentucky Derby. So make sure to go through this, understand these topics, that outliers require some special attention. We might remove them. They might be due to errors, but we don't just remove them without looking at them first. You don't just remove outliers. You actually take a look at them. So here is the first question. We'll change that to overview of the chapter real quick. So that was more an overview of the chapter than it was the first question. Wonder if people will watch that part of the video. Maybe they won't. So overview of chapter 4. Chapter 4 overview. Or speedrun, let's say. And then no one will watch it. Oh, it's 2-minute speedrun? Holy mackerel. Oh, that was quick. Stat 201. If you like that, tell me. Say, hey, Brian, do more of that right there. Chapter 4 homework. Question 1. Okay. So now we're on the first question. The Research and Innovation Technology Administration of the Bureau of Transportation Statistics reports, so people report load factors, passenger miles as a percent. So that looks like a quantitative as a percent of available seat mileage for commercial airlines for every month going from here to here. Here are histograms comparing the domestic and international load factors for each of the time period. Compare and contrast the distributions. Okay. So we get two quantitative distributions. They could have stacked these. That would have been nice. We have the mean, the median, standard deviation, the IQR, and the sample size. You've got an important note right here. N is sample size. And both of these look to have left skew. So if you look right here, this is definitely left skew because it's pulled to the low side. And that is going to lead me, if they want to know the proper measures of center and spread, because of the left skew right here, we got a little monster man, right to the high, left to the low, whatever way the monster man's tail goes. That is going to be a left skew towards the low side, negative skew. So that one is more left skew. What do we got with the compare and contrast right here? Both distributions are unimodal and left skew. There we go. Okay, so that eliminates this one. They're both unimodal and left skew. The medians are very similar. Okay, let's look at those medians. No, they're pretty different. 82 and 79, or that's 79.7. It's somewhat of a difference. If you look at standard deviations and IQRs, that the unit differences, I mean, it's about a unit difference of 2.5, which is, sizable for this distance. So I probably would go, oh, they're saying they are similar? The IQRs show that the domestic load factors vary a bit more. Okay, so where are the IQRs? Here's the IQRs, and the variability is higher for domestic. Okay, so the domestic, so this could be a candidate answer. They're not uniform. Uniform means flat. So make sure you know what the word uniform means. These do not look uniform. Uniform would be something like that, and that's not uniform. That is unimodal, and definitely left skew. So the medians didn't look very similar to me. But that's the only choice we have. The medians have a difference of 2.6. The IQR shows more variability in domestic, and that's a metric of spread right there. So that should be it. Boop. Decent question. Subjective ones are sometimes the hardest because what exactly are they looking for? Well, that varies from question to question. The box plots show the fuel economy. So we've got a box plot right here with an extreme outlier. And it's worth noting, like we said, that sometimes an extreme outlier could be noted with a star. So they could have put a star right here because that's way more. If we look at an IQR, that's 1 IQR, 1.5. That's really, I'm surprised that's an outlier. That's a lot of IQRs above. Like, I'm just trying to draw the length of an IQR, which I failed at originally. That's probably just a very light outlier right there. But there's one outlier, and then there's one extreme outlier. Very important to know that is an extreme outlier there at 112, and also you can get the data value. So this extreme outlier is at the max. The Q3 is right where the top of the box is. The Q1 is right where the bottom of the box is. The min is the bottom of the box right there, the bottom of the whisker, I should say. And the median is right here. The max is this value up here, but be careful. This value is an outlier, which probably something like 32-ish. I don't know. Where it lands on this number line down there. Standard deviation is a measure of variation. We sampled 667 individuals, just 67, which would indicate to me the right skew from the outliers. But are the right skew, it's maybe more just due to outliers. Why is that? Well, the mean is impacted by outliers. So if you see here, the mean is over here at 23-ish, and the median is over here at 22. So 22 median and 23 mean. So this is where the median is at, and this is where the mean is at. So the mean follows the skew. Really great note we need to have, and it's probably going to go in that direction because those outliers are pretty big. How will removing the electric car affect the standard deviation? So that's an electric car up there, it's saying. So standard deviation is a metric of spread from the mean. Can you direct me to the tutorial for downloading jump? Yeah. We'll do it right after this. Thank you so much. And remind me, we'll do it right after this, Chandler. You got it. So the standard deviation is actually calculated from the mean. If we go and look at the formula again right here from chapter 2 slides, we can see how it's calculated specifically. And here we are on the screen. It's something's distance from the mean is going to increase the standard deviation. And so here is the formula up here that says the observation's distance from the mean squared, and we sum those distances. We divide by n minus 1, and then we square root it. You don't need to know that in depth, but the further things are away from the mean of the data, the more they increase the standard deviation. And standard deviation is a measure of spread. So if we remove this point right here, that would decrease the standard deviation because there's less spread to the data. The standard deviation will be much lower. That is correct. So it's one of these. Since the standard deviation is calculated by summing the data values, no. The standard deviation will be much lower since the standard deviation is calculated by summing the squared differences between the data values. There it is right there. And that is literally what we see in the formula for standard deviation. It's the squared differences between the mean and the observed value. So that's the difference between the observation point and the mean of the data. And then we square those and sum them. And that is literally what it's saying right here, since the standard deviation is calculated by the summing the squared differences. So also, I would say on the more mathematical level, it's just going to be the spread of the data is smaller. How will removing this affect the IQR? Well, the IQR is just the middle 50%. It's really not going to change much. The IQR will not change much, and that's all I would need to know about it, because the IQR is the range of the middle 50%. And so if you had people standing in a line, so if we were to take some sort of data right here, and we had 1, 2, 3, 5, 8, and 100, and the middle 50% is ranged right here, well, this outlier is not impacting the IQR really. It's just kind of a guesstimate of the middle 50%, but removing it would just kind of shift where the middle 50% is a little bit. Actually, maybe it's right about here now, but you're really not seeing a big change. Outliers do not impact the IQR, and that's why we would use something like the IQR as a measure of spread. So that's really a good question right there to think about what we use and why. So let's go get that jump tutorial right there on downloading jump. Let me take a guesstimate of when I did that question. 933, Stat 201, Chapter 4, homework. Question 2, check time. Okay, so for downloading jump, let me go to the visualization playlist, and then we'll do the next question coming up here next. But the visualization playlist should have it. Is it Mubot going to do it? Visualization. Mubot, are you awake? Mubot's not awake. There we go. Let's wake up Mubot here. He's destroying the universe as he appears. And so we're going to get the visualization playlist on here. And I can get it this way. And installing jump. Okay, here we go. I found it. And here is how to install jump for a Mac or a PC. The Mac is the first one. The PC is the second one. And here is installing JMP. So there you go. Make sure to click the second one if you have a PC. And if you have any issues, let us know. Every once in a while, issues can arise. But let us know if you have issues installing Jump. And that's how we install Jump. So let me know if you have any issues. Thank you for asking right there, Chandler. 50 points in the chat. And I recommend you taking time to try something, search it. Yeah, exactly. Thank you there, Sloan. Great advice. Another 100 points right there. Why not? Mubot was asleep right there. So now we're going to mark this in the video right here. This is the next question at 1433, Stat 201, Chapter 4. For homework, question 3. Okay, let's talk about how to do this right here. You're welcome, Chandler. And this one says the accompanying graph shows load factors. And let's take a look. We're seeing box plots now. So we have side-by-side box plots, and they're very ideal for comparing multiple distributions. Once again, they are ideal for comparing multiple distributions. And you can see right here some extreme outliers. That means something way below in the 4th month, April right there, January, February, March, April, May. And you see some sort of time order pattern to this. Good to see you here, Abigail. It does take a while. You are right. And does everyone notice the median slightly changes? There's differences in the IQRs. There's outliers at some months. So, there's really variation in between the months. You would say here that your highest months are the summer/fall months. The lowest months are the start of the year, especially February has a big dip. There's some extreme outliers for a few months. And yeah, that's how I would talk about it, especially if you had to do a write-up. Load factors are generally highest and least variable during the summer months, I said, right? That looks right. They are lower and more variable in the winter and spring. Okay, June to August. August is the 8th month, right? August is the, yeah, that's right. There we go. June to August. Okay, good. Yeah, that's all you got to notice, right? Just Notice where the medians are at. Oh, there you go. Is that it? That's it? Well, that was easy. That was quick. Well, I thought we'd do more analysis on that. I was all ready to do a whole deep dive into the analysis. But yeah, well, that's nice. Nice, easy question. But know what you're looking at. Know how to interpret the graphic as I get ready for the fourth question right here. And once again, don't, you could just see the answers here in a second, but think about what the box plot is showing you. Let's take this and use it to talk about a box plot right here and bring it to the screen where we've got a box plot. Okay, so we need we did some earlier. Where's our box plots? That's not the box plots. Where's the box plots? There's box plots. Okay, so these are the box plots we made earlier. Check out the earlier office hours where we did the visualization, and we have box plots down here. So we can talk about this question and then highlight the things it's talking about to see if they're true. Okay. So these are side-by-side box plots. Side-by-side box plots are when you have a categorical X and a quantitative Y. Notice here, side-by-side box plots, categorical X, quantitative Y, and that's what makes a side-by-side box plot possible. And you see it on the screen, we have class of passenger on the Titanic and the fare they paid. So the first thing says, the center of a box plot is a box that shows the middle half of the data. That is very correct. That is called the IQR. This is the question for exams. Is there any designated amount of time? We have the exams 90 minutes. Sloan, good question. 50 points right there. 90 minutes for the exam. And this is the IQR. And that is a right answer. Go blue. That is right. The center line of the box plot signifies the median. You bet it does. That's the median right there. And that's another right answer. Box plots are great for comparing. What do you think? Are box plots, plural, great? And that's not a box plot, but box plots are great for comparing multiple groups. Yes or no? Are box plots, plural, great for comparing multiple groups? Are box plots, plural? Oh, yeah. Side-by-side box plots, great stuff. The values which are a dot, by a dot or an asterisk are outliers, and we could go back to the last one because sometimes they do that in some things. Sometimes they put an outlier as a little dot, and Abigail's right for another 50 points right there that this is true. So you should know where the outliers are at. They could be dots or stars. Stars are for extreme, and some graphical software will do that. So everything we just saw there is true, but don't just mark true, true, true. Make sure you understand why they are true. Make sure you could go to a box plot and identify those things and know where Q1 is at, know where Q3 is at, and you're doing well on that. So building on the questions, there's a certain amount of questions you have. Usually about 40. Good questions, Sloan, keep asking them. Usually about 40 questions. I think, can you preview it? Not preview it, but I think you might be able to like see it. Like see, like, might say like exam such and such at this time. It might. It might. Chapter 4, homework. Question 5. Let's do question 5 right here. So here we go with question 5, another of the load factors. This is very important to them. Whoa, so look at this. We got a big increase from year to year to year. So you can really see the increase in medians right here. Once again, we're comparing multiple groups with box plots. The median is increasing. You might say, you know, what's the deal with this box plot right here? So Sloan or Abigail or anyone watching, what's the deal with this box plot right here? Like, what does the value right here represent? That's a bit odd. I'm going to take a quick snack right here. What does that value represent? Nope, not an outlier. Good answer. Not an outlier. This is the only outlier. It's a good question then. That is the max. But it's also the what? That is the max for that year. That is the max. But it's also the what? It is the max. There's no whiskers. And it's also where the what is. It's a weird box plot. That is the max. But it's also where the what is. It's a lot of data like compiled right there. So that is the max, but it's also where the what is. What's the top of the box? It's also where Q3 is at. Oh, well, the upper fences we never see. You won't. So the upper fence would be somewhere. It'd be What do you think I'm trying to find if this is where the upper fence is at? The upper fence for it is somewhere there. And what did I try to graphically draw right here? What do you think I tried to graphically draw above Q3? I tried to graphically do what? That's probably about where the upper fence is for that one. I tried to graphically go Q3, which is where the top of the box is, and then I tried to add to it 1.5 IQRs. Because the IQR is the literal distance of this box, so I was trying to add on top of it. Does that make sense right there? 1.5, 1.5 of those distances right there. So I tried to go above Q3 and go 1.5 IQRs. Now remember, do you see the fences in the final product? When you make your final box plots, do you see the fences? Do you see fences here? Are there fences here? In the final, no, you don't see fences. They're just a graphical technique. And the upper whisker could go up to the fence. So what we can do, and this might help a lot of people understand, because I think usually just seeing new data helps, is make our own data right here and ask people something like push-ups they can do. Now let's say Brian's working out and he's recording how many push-ups he can do. And here we go. This is a day's worth of working out and push-ups. There we go. Now take a look at the data and how it looks in a box plot. When we make it into a box plot, this is the box plot. Why is this the box plot? And the answer is over there on the side. So that is a box plot. Why is that a box plot? That is a box plot. Why is that a box plot? That is a valid box plot. Like, that's a box plot? Oh, yes, it is. Why is that a box plot? Like, why does it look like that? We'd say to someone, there's no blank in the data. There's a lot of ways to talk about this and be like, well, everything's this, or there's no blank in the data. How do we talk about it? Why is that a box plot right there? That is a box plot. And why is it a box plot? So look at the max, the Q3, the median, the Q1, the min, and there's the data values. Everything is all the same, right? There's no variation in the amount of push-ups Brian did. So watch what happens when I start to change the values. If I do one push-up now, guess what? That is, was it not going to update? There it goes. That one push-up is an outlier. Why is it an outlier? Because right now, what is the calculation of the IQR? What is the IQR? So mathematically find Q3 minus Q1. The IQR is equal to what? Mathematically right now, the IQR is equal to what? It's equal to 0. So there's such little variation that 1.5 IQRs would be still at here, and anything outside of 0 is unusual now. Let's make this more interesting. This is a more interesting box plot here. You see it start to build. We don't want 67. That destroyed it. So this is more interesting. Now, these are the tougher questions, and where we will start class today. I'm actually going to change the data a little bit. Excuse me. I don't want the numbers to be so weird. Got to go up here to the 5. There we go. I love it. Okay. What is the IQR? First question right now is, what is the IQR for this box plot? And you can look at the IQR here. And that's the answer to the IQR, like that distance. It's 3, right? You go Q3 minus Q1 is 3. So then the tougher question is, which sometimes we have a question like this, where is the upper fence? Where is the upper fence? So where is the upper fence on this box plot as I almost destroy it there? Really? Oh, I can't change the axis right now. Where is the upper fence on this box plot? The upper fence would be located where? I think you're right, Sloan. So the mathematics we have to do, I'm going to pin it here, is Q3 plus 1.5 IQRs. So Sloan found that IQR is equal to 3 via Q3 minus Q1, which was 6 minus 3. So that's equal to 3. And then we went to Q3, which is 6. So the answer is 6 plus 1.5 times 3 equals to 10.5. So when we do this right here, watch this. If I take the maximum value and go to 10.5, it is now at the upper fence. But if I make it 10.51, it becomes an outlier. Does that make sense? So do you see the fence right here? The fence is right here at 10.5. You do not see the upper fence. The upper fence is here at 10.5, right in here somewhere, but this is right beyond the upper fence. And let's go back to the control panel again. And now let's take 8, and we'll move 8 up to 10. And why is there this little area? Is this where the fence is at? Why is there this little area right here? Because take a look at the data. Why is there this little area right here? Why is there that little area right there? Like, you don't see the fence, Mary. You don't see the fence. This little area right here represents that there is no data between 10 and 10.51. But if I put the new point up to 10.5, you can see it's right up there. You'd have to zoom in really close, but the fence is at 10.5, and this one point right there is beyond it. Does that make more sense, Sloan? How are you doing on that? We can move that back down, but this just is the maximum value. That is not an outlier. That is the minimum. Yeah, which one do you have, Taylor? We might have just enough time to do one question on it, because we're going to start class here in 15 minutes. Name a question you want to do. We're going to finish off this last question, but name a question you want to do. Air travel after extraordinary events was typical. After extraordinary weather events are not typical. Oh my gosh. So look at the accompanying plot. There's an outlier in 2015, probably due to a blizzard that dumped snow. So there's the outlier in 2015. So that's 2002. Air travel after extraordinary events was not typical. Good. In order to analyze monthly patterns, it's best to leave these days in the data. I would say it might be best to set these days aside. So, yeah, that was an interesting question. Hey, you good to see everyone here. If someone has one more question, we probably have enough time because we're going to start class here soon. Let me say in the announcement to class, that's the full quiz right there and review of the chapter, kind of. So we did a full quiz, but tell me which question you want to do. And we'll take a look right here. So a little bit of chill music. And let me get the link for today's class sent out. Say class in 15 minutes or class in 14 minutes. Why does it send me there sometimes? Wait, it says 73 minutes? That's not right. Did I put it to 2:30? Ay. I think I thought Knoxville time. There we go. Hopefully no one saw like 2:30 and was like, wait, what? Class in 13 minutes here. Class in 13 minutes. See you soon. Click here. We got the full homework done today. The serial question? Well, let's go to the serial question, and then we'll end with that. The serial question. Dun, dun, dun. Okay, chapter, which one was it? Chapter 4 quiz, serial question. Settings for class. Oh my gosh. Leave those settings. Chapter 4 quiz. Replace questions. Is it the adult and children's cereal? I find it nice and quick. Oh, we see cereal. Just enough time, Taylor, I think. How does the question start? Here we go. I see it. Sugar is a major component. Let me mark this in the video, and then we'll head off here in a moment. Sugar is a major component. Thank you, Taylor, for asking this. We did a lot on that chapter, that last one. So, Stat 201, Chapter 4 quiz. Sugar is a major component, ingredient. Okay, let's look at some sugar questions right here. Nice job, Taylor. Thank you for repeating that for me. What is the range of the sugar content? So to look at this, the histogram might trick you because on the histogram has bins. That means values are contained between 60 and 70. Values are contained between 0 and 10 if they fall into this bin. and there are 13 values that fall into that bin, and there's only one value that falls into this bin. The height of the bin is the amount of cereals that had sugar in that range. You actually need to look at the side-by-side box plots right here, which are going to tell you that the minimum value for adults was 2, and the maximum for children was 64. So all we're going to do right here is take max minus min to get range, and is 62. Be careful, look at the box plots, which give you the exact numbers right there, and that's the range. The shape of the distribution, we've got bimodality. Bimodality is when you have 2 peaks. So we see a bimodal distribution right here. That's probably due to children's cereal generally has more sugar and adult cereal generally has less. So there's some bimodality here. It's not really skewed. It's more bimodal. So it is bimodal, not uniform flat or unimodal one mode. What aspects of the breakfast cereal might contribute to this? Most cereals have similar. That'd be uniform. Cereals tend to be either very sugary or it could be. Sugar content varies. That'd be a high spread. So they either tend to be very low or very high. Are all children's cereals higher than adults? The answer is yes. Because if you take a look at all children's cereal, so you go right here, you can see they're higher than the max of adults. So the min of children is higher than the max of adults. That's definitely true right there. So that is a yes. Which group of cereals varies more in sugar content? So variation is going to be a measure of range or IQR. And if you take a look at the IQRs right here, the adults have a larger IQR. Once again, this goes to the knowledge of box plots, that on a box plot, the box in the middle is the IQR. And this is the range right here. So that's the range. And the ranges look to be similar. But the IQR for children looks to be smaller. And IQR is a measure of spread, as is range. And box plots are going to generally show you better the IQR, which is the middle 50% of the data. And yeah, so I would say the adults, although the ranges appear to be similar, the IQRs for children's cereals is larger for adults. So although the ranges appear to be similar, the IQR is larger for adults, and that should do it. There we go. Does that help out, Taylor? I know we did it kind of quick right there, but this is a good way to learn how to analyze box plots and histograms. Understand histograms are going to show you just one variable at a time. Side-by-side box plots, which we talk about a lot over here, side-by-side box plots are going to show you multiple. We could have made stacked histograms. Histograms are better at showing you shape, which is why we looked at the modality with the histograms, and that's got it. But really good question, and drop by anytime with those questions. We've done the Chapter 4 homework, so we could definitely do a lot more quiz coming up here. Till then, bye for now, everyone. Class in 8 minutes.